Hello and welcome to yet another webinar from Roboza. In this webinar, I'm going to show you how to write a simple program in WinAVR and download the source code into your microcontroller. So, what are the basic requirements that you need before you proceed? The very first thing that I'll assume is that you have already installed WinAVR, any version of it. But if you have not done so and you do not know what WinAVR is and how to install it, then please visit my earlier webinar titled Introduction to WinAVR, hosted on YouTube. At the link http://www.youtube.com/user/roboza. Okay. I'll also assume that you have the very basic understanding of C programming language and you know how to write a simple C code. But the most important thing in order to complete this webinar is that you need to learn something about the registers that are used in the AVR microcontroller. Yeah, don't worry, don't sweat it. It will be covered in this webinar itself. Okay, let's begin. So, what is AVR? Well, AVR is a family of microcontrollers built by Atmel, and this is a very popular microcontroller from Atmel, that is AT-MEGA16. It has 4 ports: port A, port B, port C and port D. Well, let's see what its features are. There are 32 general purpose 8-bit working registers. This microcontroller can work at a maximum of 16 MIPS through a 16 MHz clock crystal, external clock crystal. It has 16 kilobytes of in-system self-programmable flash memory. It has 512 bytes of EEPROM. It has 1 KB of internal SRAM. There are 2 8-bit timers, 1 16-bit timer. There are 4 PWM channels. There is a ADC, 10-bit ADC, 8 channel. The port A basically works as an ADC besides general purpose IO. There is a serial USART. There is a SPI connector. There is a programmable watchdog timer with separate on-chip oscillator. There is on-chip analog comparator. There are several sleep modes to save power. There are 32 programmable IO lines and many more. What's more interesting is that this microcontroller can work to as low voltage as 2.7 volts. Okay, now that we know about AT-MEGA16, let's see its IO registers. As a beginner, we'll look into the 3 basic types of IO registers that are used in AVR microcontrollers. These are DDR, PORT and PIN. DDR stands for Data Direction Register, and as the name suggests, this register defines the input or output behavior of a port. But remember that unlike PIC microcontrollers, AVR microcontrollers are not bit addressable. What I mean by bit addressable is that in AVR microcontroller I cannot assign 1 bit of a port as input and the other bit as output simultaneously. Okay, the port register defines the value that is to be outputted onto the port pin if the port has been assigned as output, but if the port is assigned as input, then it will enable or disable the pull-up register. Finally, the pin register is used to read the status of the input pins. That's it. Now, suppose if we want to build our own hardware, then in order to test our code, how should the hardware look like? Well, it looks like this. There is a LED which is connected to port pin PA0 and it is made active high, which means that if I make the port pin PA0 high, then the LED will glow. There is also a switch connected to port pin PB0 and ground. So if basically if I switch on the switch, then the port pin PB0 will be connected to ground. Okay. Now what we need to do in this project or in this webinar will do is we'll make the LED glow initially, and then using the switch we'll turn it off. Also notice that we will enable the pull-up resistor for PB0 pin because we are making this pin as input. More about this later. Now let's see how we can make the LED glow. We need this code to be written in our program. DDR A equals 0xFF. This means that the data direction register of port A has been assigned the value of FF in hexadecimal. Hence all the port pins are made output. Conversely, suppose if I give it a value of 0, that is DDR A equals 0x00, then all the port pins will be made input. Now that we want to make our LED glow, we have to give a high output onto the port pin because we made the connection in such a manner. Okay, for that we'll use PORT A equals 0xFF. If we made the port pin as output, then selecting PORT register and giving it a value of 1 will output high, but if we give it a value of 0, then the output will be low. That's it. So we have two lines of code to make our LED glow. DDR A equals 0xFF and port A equals 0xFF. Okay, now that we know how to make our LED glow, how do we make a port input and enable the pull-up resistor in order to use the switch? We use this code DDRB equals 0x00. As I said, that this will make the port pins of port B as input. Now we need to enable the pull-up resistor. For this we use port B equals 0xFF. Notice that since we made the port B as input port, the PORT register will enable us to choose between enabling and disabling pull-up resistor. So if we give it a value of 1, it will enable the pull-up resistor, otherwise it will disable it by giving a value, if we give a value 0 to it. That's it, we're done. We have two codes to make our port input and enable the pull-up resistor. But how do we use the switch in order to turn the make LED off? Well, for this purpose we need to read the status of the switch, or rather the status of the port pin to which that switch is connected to. We can read excuse me, we can read the status of a port pin by using PIN register and check whether it is high or low by using this command. That is, we use a if conditional statement and PINB. Using a bitwise AND in between, we can choose which pin we want to check. That means if here 0x01 means that we are checking the PB0 pin, and notice here not if we are checking for a low condition. If we are checking for a high condition, we do not use that not. So that's it. We can check PB0 using these two lines, or rather any one line according to our requirement. So our code will look like this. If not pin B, if not pin B 0x01, then if this condition is satisfied, we will make the LED off by giving the port A equals 0 statement. Otherwise we'll give port A equals 0xFF so that it remains on. Alright, let's see how to actually write the program on our notepad. For this, I'll first create an empty folder and name it as my underscore input underscore output. We will save our work in this folder. I'll open the programmer's notepad, WinAVR, and we'll write our code here. Just a minute. Okay, oops. Alright, we are done with the settings. Now let's save this blank file into the folder that we just created here, and we'll name it my underscore input underscore output dot C. Note that I am giving the extension .c here. We'll save it. Yeah, see, my file has been saved, though it's empty. We'll paste in some pre-written code in order to save time, and I'll explain what I have written. Here we see include avr/io.h and #include util/delay.h. The io.h is a header file that is required in order to understand what DDR A, port A, etc. mean, but the delay is not used in this program. We can use it to give software defined delay of say 500 millisecond or something. We'll cover this in some other webinar. Okay, as defined in the earlier part of the webinar, DDR A will make the port A as an output if I give it a value of 0xFF. Since the LED is connected to port A, pin number 0, we need to make this port as output. We give it an initial value of 0xFF, so our LED will be on initially. Since our switch is connected to port B, we'll make port B as input by giving 0xFF to the DDR B register, and we'll make the pull-ups enabled. So port B equals 0xFF. Please note the different functionality of PORT register in case of output and input ports. Since our microcontroller does not have any operating system, we need to run a infinite loop. So infinite while loop will do. Here I'll check the status of the PB0 pin, that is the switch. So if my switch is pressed, that is if the PB0 pin has been grounded, then I'll turn off the LED, else I'll keep the LED turned on. That's it. This much and you are done. We'll save it and we'll try to compile it. Oops, what's wrong? I've written the code right. But wait, you see? Yes, you got it right. I have not made the make file. You need to configure the make file before you can compile the code. Remember, I showed this in the last webinar. Here you can make the make file, or rather edit the make file. Make file, enable editing from last option, then give the main file a name from here. My file name is my underscore input underscore output. Please note that I am not giving the extension .c here. Target equals my underscore input underscore output without any extension. Now in order to change the frequency of the CPU, we have the crystal that I am using is 16 megahertz, so I am giving it a frequency of 16 megahertz. Let's choose the microcontroller type. I am using Atmega 16 for this code, so I'll use Atmega 16. Okay, MCU name has been changed. Now I need to configure the programming port to USB, and since I'm not using STK500 V2 programmer, I have to edit that. I'm using a USB ASP programmer, so I have to write USB ASP in place of the AVR programmer, and save my make file into the same folder in which my source file is. Yeah, it's here. Please note that I am not changing the name of this file from makefile to any other name. Let it remain makefile. It's absolutely necessary. Okay, we have saved the makefile, and here is my source file. Now you can get rid of this window. Okay, I'll try to compile it once again. And voila, it has started. If everything goes fine, you will get process exit code 0 like this. If you have any error, it will show, and if you have warnings, you can neglect them. You can check the program size from here. My program costs me 134 bytes of flash memory. That's very less. and I can program my microcontroller from here. Alright, remember to connect your microcontroller to the power supply before you download the code, otherwise it may not work. Anyways, that's up to you. Let's see how the real world application works. This is the Atmega 128 board that I have with me right now. It doesn't matter whether I choose Atmega 16 or Atmega 128, the code will be same. Here the LED that glows, this LED is connected to port pin port pin PA0, and the switch on the left hand side is connected to this one is connected to port pin PB0. These are surface mounted switch, so it's very small. So basically if I press the switch, the LED will be turned off, and okay, I don't know why this is not working. It should work. I'll try once again. Alright, here you go. See, I'll press the switch and the LED goes off. I'll release the switch and the LED comes on. Press it, off and on. That's it. Thank you for watching. You can visit Roboza at this or leave me any comments and doubts or suggestions, whatever you have. You have been listening to Sohail Alam. Thank you for your support.